All right, welcome back, folks. I'm sorry if the last video ended a little abruptly. There were some technical issues that I had here. Hopefully those won't happen again this time. In the last video, we talked about using hypothesis tests for means when you did know the population standard deviation. Now we're going to talk about when you don't know the population standard deviation. The difference is the same as for confidence intervals. We're just going to use t-values instead of z-values. So we're just going to talk about performing some more hypothesis tests and a little bit about interpreting the results as well. So again, z-tests are easier to understand and they're easier to calculate, but they are not always practical to do. Very rarely are you going to know the population standard deviation unless you measure every person in the population. That basically never happens. And so instead of using the population standard deviation, we have to use the estimate from what we have in our sample. And so we use the sample standard deviation. When we do that, the probabilities change just a little bit, and so we have to use a different distribution to calculate the probability. And so we use a t-test or a t-distribution, right, which you've seen before. Right? We can't really know the population standard deviation, and so we just adjust for the t-distribution, and there's more area over here, which just means that it's a little more likely in some cases and a little less likely in others. Okay? As you approach the population size, the degrees of freedom increase, and then eventually you get to the z-curve anyway when you've measured the entire population. There are different types of t-tests because we can use this t-distribution in lots of different ways. The differences between these tests are the differences in the types of questions that they can answer, but also in how you calculate the t-value. But beyond that, the interpretation of them is all very similar. And the probabilities that we've discussed in the last section and that we're going to discuss in this section, they all can be understood in the same way. Okay, so in this section, we're going to talk about what's called a one sample t-test. And then in the next chapter, we'll talk about the other two types. Remember that for these types of hypothesis tests, we want our values to be ratio or interval. In some cases, you can do this with ordinal data, but there's more restrictions to that. You want to have simple random samples. You want to know that the data are essentially normally distributed or symmetrically distributed, and you usually want a sample size that is above 30. To calculate the t-value that you're going to use in the hypothesis test, the formula is very similar to calculating z, right? With the main difference just being you're using the sample standard deviation instead of the population standard deviation. And when you calculate and find the values in Excel, the critical t-values, and when you find the p-values, the probabilities, they'll all work very similarly in Excel. You'll just use slightly different functions to calculate those, or you could use the tables as well. But the general idea of what we went through in the last section is all the same. And so we're going to do another couple of hypothesis tests, except we're going to do this with t-tests. The mean annual tuition and fees for a sample of 14 private colleges in California was $30,500 with a standard deviation of $4,500. And so that means we have a sample mean of $30,500, and a sample standard deviation of 4,500. The sample size, we have a sample of 14 private colleges, and we can assume that the population is approximately normal. That's all we need to know that the t-test that we're going to do is going to work. And then can we conclude if the mean tuition for private institutions differs from 30,000? We're going to use an alpha level of 0.01 in this case. So 1% rather than 5%. And the critical value method. So step one, we're just going to find our hypotheses. Remember, we're comparing whether our sample differs from 30,000. So the null hypothesis is that the mean is equal to $30,000. The alternative would be that it's different from 30,000 or it's not equal to. And so here we have our null hypothesis and the alternative. The next step is to calculate the t-value. So again, t is very similar to z. Is the mean of the sample minus the mean or the value we're comparing to, sample standard deviation divided by the square root of n. And so this is 3,500 minus 30,000 divided by 4,500 over the square root of 14. That's 500 divided by 1202.6755. We're just going to keep some decimal places until we divide and get a t-value of 0.416. Now, the letter's different in z and t, but the way you think of a t-value is very similar to the way you think of a z-value. A really large z-value tends to mean that your sample or your score is very different. Small t z value means that it's close to the mean. Same is true for t. A small t value means that your sample is close to the mean. A large t value means that it's not. And so let's determine if this is significant. If we want to use the critical value method for a 0.01 level of significance, then you're going to want to type, in this case, we're going to want, let's see, it is a two-tailed test because we're looking to see if it differs. And because it's a two-tailed test, we want the t value. Oh, that's right, we're doing t, so we can find the t value relatively easily. The degrees of freedom is equal to 13 n minus 1. And so in Excel, we can type equals t dot inv dot 2t, and then our t value. Oh, I'm sorry. And then the probability and the degrees of freedom. And this should give us our critical t. So the critical t value is 3.012. And so this comes from Excel. And so that means way out here. And our t value that we calculated, 0.416, is somewhere here. Remember that the critical value method means that our value should be further away from the mean than the critical value, right? It should be in the rejection region, which would be out here. We would also have a minus value over here for t. And so our t value is not within the rejection region. And so we are going to fail to reject the null hypothesis. There's no evidence to conclude the mean tuition is different from $38,000. Okay, so make a decision about the null and then write a statement in terms of the alternative. Let's try one more example with the t value. Coin-operated drink machine was designed to discharge a mean of 8 ounces of coffee per cup. In a test of the machine, it discharges in 20 randomly chosen cups. Okay, so our sample is 20, and we know the population mean value is 8 or 8 ounces. The sample mean and sample standard deviation. So the sample mean is 7.82 ounces. Sample standard deviation, 0.29. If we assume that the discharge amounts are normally distributed, is there enough evidence at the 0.05 level of significance to conclude that the true mean discharge differs from 8 ounces? Okay, so let's take a look at our hypotheses. Our null hypothesis just states that the mean is equal to 8 ounces. The alternative is we want to determine if it differs from 8 ounces. And so now we want to calculate our t value. Right, step 2, we want to find t. In this case, again, I'm just going to write the formula. Our sample mean, 7.82, minus the value we're comparing it to, which is 8. Standard deviation of 0.29 divided by the square root of the sample size was 20. And if we calculate this, negative 0.18 divided by 0.0648, negative 2.78, or well, let's call it 775 or 776. Go to 3 decimal places. So now we want to use the p-value method, which means we're going to find the probability that we would randomly choose this sample. And we can use Excel, again, to do that, to determine the significance. So in Excel, you could type equals t. And so let's on this here, our t value was negative 2.776. And so that's probably about right here. And I'm going to try to color coordinate this the way that I had before, 2.776. And so if we want to find the probability equals t dot dist dot 2t, then we're going to enter our t value. And the degrees of freedom in this case is 19, 20 minus 1. Now, when you use this command in Excel, because the t distribution is symmetric and because of the way the function works, if you have a negative value, you still always want to just plug in the positive value. Otherwise, it's going to give you an error. And if we do this, this will give us the probability, 0.012. And so clearly, the probability of randomly choosing this sample is less than 5%. And this would be a very rare sample to randomly choose. What's more likely is that there's something different about the sample. What's different? Well, it's not discharging the right amount of drink or coffee or whatever it is. And so in this case, we would reject the null. And we would say there is evidence to conclude the mean discharge of coffee is different from 8 ounces. And so then we have our conclusion about our test, and we have the answer to our question. In the next section, we'll talk about completing hypothesis tests using proportions and do some more examples.